Hi, welcome to the Center Maths Problem of the Week. This week our problem is a square and an equilateral triangle have the property that the area of each is the perimeter of the other. Find the square's area. All right, so we'll let S denote the length of the square and T be the length of one of the sides of the triangle. From the problem, we are given that the perimeter of the square is equal to the area of the triangle. The perimeter of the square is 4s. And the equation for the area of an equilateral triangle is square root of 3 times the length squared times one of the lengths of the side squared all over 4. And then we also know that the area of the triangle, that the area of the square is equal to the perimeter of the triangle. Area of the square is s squared. And the perimeter of the triangle is 3t. What we're looking for is the square's area, so we want to know what s squared is equal to. If we can find the value of t, then we can just plug it in and we'll have our answer. We'll use this equation first, divide both sides by 4 to get s in terms of t. So once we divided both sides by 4, we're left with s is equal to the square root of 3 times t squared all over 16. We plugged that value into s squared equals 3t. So then we squared it. We squared the whole quantity. And so we have 3t to the 4th all over 256. And we just rewrote 256 as 2 to the 8th. So now we have 3t is equal to 3t to the 4th all over 2 to the 8th. Divide both sides by t. Divide both sides by 3 and multiply both sides by 2 to the 8th. And we're left with t cubed is equal to 2 to the 8th. Take the cube root of both sides to get t. And so this is our value for t. And our last step will be to put it into this equation so we can find the area of the square. So once we plug it in, we have s squared equals 3 times the cubed root of 2 to the 8th, and we can just reduce that further, so we have 12 times the cubed root of 4. Hope you enjoyed this video. Be sure to check out our blog, check out centerofmath.org, and follow us on Twitter and Facebook. Thank you.